Hi friends, this is your friend Patodia again, and now most of you must be knowing me. Those who have not, I am associated with askIITians as Maths IIT, and I did my graduation from IIT Roorkee. Okay, so all of you must have done straight lines and you must have come across a term slope. Okay, so if I ask you what is the slope of a line, all of you will be saying, okay, we know it. You can easily answer that. But if I give you a complex curve, okay, and if I ask you what is the slope of this curve, then you will say, oh my god, is it possible? Is there anything slope of a curve? Okay, so to answer all these questions, we are at the right place, okay, and the solution to this question will be given by differentiation. Okay, so differentiation is again part of calculus which helps us in getting the slope of curves, and it will have more applications as you will study in other lectures. We will be starting with the introduction and some standard derivatives, and then I will be teaching some higher level concepts which will include logarithmic differentiation, parametric differentiation, and the miscellaneous part, which will be the crux, where we will actually study the JEE concepts. For those who are new, they will find it bit interesting and bit tough in the beginning, but those who have already studied basics of differentiation, okay, for them you can just go through first 2-3 parts quickly, and then from 4th, 5th part onwards you will find the things growing tough. Okay, you will find the heatness in the topic, and you will actually feel that how it is useful, and the tricks which I will be telling, okay, they will be especially very helpful in cracking questions in JEE Advanced and Mains. Again, this is very important topic as far as JEE Mains and Advanced is concerned, and lot of questions come in both of exams from this chapter, and this will again form basis for application of derivatives, okay, which is its separate unit. So be careful and study this chapter very well, and you should be clear with the basics. We'll be concluding our journey with some IIT-JEE questions, okay. So let's begin with the first part, and in this we will be studying about introduction and some standard derivatives. Let us look at the contents of this chapter, and again on the screen, the two great scientists, Newton and Leibniz, who gave the major concepts of differentiation, okay. So as earlier told, in this part we are going to discuss about the introduction, that what the differentiation is all about. I guess most of you till now must be having some idea of what the differentiation is, but here we are going to make it more clear, okay. Then we are going to look at the standard derivatives, okay, some differentiation rules. Then we will look at the logarithmic differentiation, parametric implicit function, and the miscellaneous part, okay. So the miscellaneous part you will find in each of my topics as I keep the JEE things in that case, okay. So whatever we are going to do, the final conclusion is in the miscellaneous part, okay. So let us begin. What is differentiation, okay? So broadly speaking, it's a process of finding the rate at which the dependent or the first variable changes with respect to another, okay. It means like if you are finding something like output, okay, output of something, okay, how it is changing when you change the input, okay. For example, if you want to look at your marks, okay, so how much more input you should give to get good marks. So that measurement, okay, in mathematics we term it as differentiation, okay. So this will bring again more clear picture, okay. So now this is the variable x, okay, and this is the variable y, okay. Now we know that this is the y is coming on the values of x. If you are putting it 0, it's coming somewhere here. Then if you are putting it here, it's coming somewhere here, okay. So differentiation says that I want a rule, okay, which gives me the rate of change at a particular point. Rate of change means that at this point, okay, if I change x, okay, now what will be the change in my y, okay. So broadly looking at this now, now this is, as you're looking here, that if you're changing x from this value to this value, then your y goes from this value to this value. Okay, so this is the change in y and this is the change in x. Now this is a very broad one. Okay, like this is the change over a long interval. Okay, but when we talk about the differentiation, we talk about at a point. Okay, why this is necessary? Again, like from 2 points we note that from 2 points it's very easy to find the slope. Suppose this point was x2 y2 and this is x1 y1. So if I change my y1 to y2, what my x1 is gonna do? So this is basically what the crux of differentiation is. Okay, in the calculus, again, this will form a very important thing. So this becomes differentiation, or we call it as derivative, when these two values become so close that there is no difference left. Okay, we are going to look at the geometrical meaning. Okay, this is the physical meaning, that if one quantity is changing, like if you change input, how output is going to be affected. That is differentiation. Okay, now the geometrical meaning. Okay, so in geometrical meaning, as I've said already, okay, the earlier one we took 2 points like this. Okay, so let me change the color here. It would be, yeah. So here I am saying the derivative means the rate of change at a particular point, which is again measured by the slope of tangent. Now again, what is slope? Slope of a line is basically constant. If I look at a line, okay, so slope basically means if you have done straight lines, you must have done slope as y2 minus y1 over x2 minus x1. So this basically means that how this is changing. Okay, so at a particular point, obviously this has to follow a rule. Okay, so now this is the actual slope, okay, which we are targeting. Okay, now what happens that when I'm saying that y2 minus y1 over, now in this figure, this is x1 y1 and this is x2 y2. Okay, now if I join this one, okay, so you are seeing that this was the earlier slope, this is the slope of from this, which is we can say near to it but not exact. Okay, now what happens if I bring the point more closer? Okay, suppose like this. Okay, now the actual slope is this. Okay, and this slope will also be very close. Okay, so as the point is coming closer, okay, this point is shifting towards this thing. Okay, so we say, you must have studied in the limits that is what the limiting is. We are saying that x2 is tending to x1. Okay, this can be from both sides. Okay, we will understand that thing also, what is left hand and right hand part. Okay, so this thing I'm saying that this becomes so closer that there is no point in between. Okay, so at that point we are getting something called dy by dx. Okay, basically our change in y was represented as delta y and delta x. When this x2 is becoming so close to x1, we write it as dy by dx. Okay, and this will form the crux of differentiation. Okay, that now we are learning like this, but then we will generalize some common formulas. Okay, so on the basis of which we are going to do the differentiation later on. Okay, now the meaning, the necessity of differentiation is like whenever like there are many models, like many systems, like you drive a car. Okay, you put a pedal. Okay, how much it should accelerate? Don't you think that putting a pressure is the input and the change in the speed of car is an output? So there are n number of examples. Volume, when you increase the volume, okay, so how much you should press to increase the volume. Okay, so everything is related, like one thing you're doing and that is an effect. Okay, so that effect basically we can give in terms of mathematical models if we are having some relation between the two terms. Okay, so that relation we find, and then we see that okay, this much of pressure I'll put and this much of output I'll get, or this much of work I will do and this much of output I'll get. Okay, so moving on to next, the first principle differentiation. This is a very basic thing. Like from which all the rules, which some of you might have already studied, are derived. Okay. So it says that dy by dx is equal to limit h tends to 0, f of x plus h. Now this is again what I've just said. Okay. Now I'll make that how that makes sense here. Okay. I said 1 point and this one x1 and x2. I was saying that x2 becomes x1 tending to x2 tending to x1. So can I write x2 minus x1 is tending to 0? Of course, if you are saying one quantity is approaching towards the other, if you take the difference, that has to be 0. Or we are saying that x2 minus x1, let this be quantity be h, such that if this tends to 0, obviously h also tends to 0. Okay. So instead of what they have done is like what is written here is like x1 y1 x2 y2. They have written that this point is x1 plus h and this y2 is f of x1 plus h and this is f of x1. Okay, that's what the story is written here. Okay, this, if you look, this is y2, this is y1, and h we have defined here is x2 minus x1. Now what is the condition? I said that x1 should tend to x2 or x2 should tend to x1. So they have written that this, if these condition is satisfied, then this is true. When this is true, we can change the limit as h tending to 0. Okay. Now limit, I guess, is a prerequisite which you all of you should have done before this chapter. Okay, because without limits it's very difficult to understand that what we are dealing with right now. Okay, so if you have not done limits till now, stop it right now and first go through brief of limits and then come back again. Okay, so here it says limit which is a function of x. Okay, now again this is a technical one. It says that the limiting value of the function, okay, is called the derivative. Okay, limiting value means when you're saying at the two values like corresponding to one input and in the neighborhood of that limiting values, okay, is known as the derivative. Okay, the difference between the ratio of this thing. Okay, and this again is denoted by f dash x. Now x means the point x, okay, where you are measuring this x1. If you are looking derivative here, you're gonna put f of x1. Okay, you will get the values. First, by this you will get a function, and corresponding to x you can get the different values of f dash x at that point. Okay, okay, now this is clearly written here. Okay, so now if I need to find the derivative of 1 by root x, okay, perfect example. Okay, so what I'll do, I know this thing that f of x is equal to 1 by root x. Okay, okay, now what we require, f of x plus h. So f of x plus h is root x plus h. Okay, now we will just find the derivative using the first principle. Okay, now right now we are deriving it. Okay, and once like we are familiar with the differentiation concept, we will be doing it using the standard formulas. Okay, so if I write dy by dx here using the above definition, okay, so this goes like this: 1 upon root x plus h minus 1 upon root x over h limit h tends to 0. Obviously, now what is the main thing which we are dealing here is like we need to remove this h, because right now if I put h, it becomes 1 by 0, that is infinity. Okay, so what we can do is we just need to simplify the expression. Okay, so this will get root x minus root x plus h over h into root x into this one will go root x plus h. Okay, now what we need to do, we need to simplify it. Okay, so obviously the best solution which I am looking at is like if I can rationalize this numerator. Okay, so what I'll basically get is this is root x plus h here over root x plus. Now I can see that x minus x, this identity will give me basically a square minus b square. So this in turn will give me x minus x, and that will be minus h. This will get cancelled out, and the denominator, this h will get cancelled with this one, and then we can obviously put h is equal to 0. Okay. So you will look at this like this will just become h will get cancelled with this. Okay. So I'm writing it here. Okay. And I'm now putting h is equal to 0. Okay. So minus 1 over, this is root x, this will also become root x, and this will become 2 root x. Okay. So 2 root x into root x into root x. Okay. So that will be 2 will be here, and there will be 3 root x. Okay. That will be x into 3 by 2. Now you will learn this rule as like in terms of formula itself. Okay. Later on, that how does this come, but the proof of every standard derivative lies in the first principle of differentiation. Okay. So these are some standard derivatives. Okay. So what you have to do right after this thing is like first note down all the derivatives. Okay. Now this one we just did. Okay. If you look at that, it was 1 upon root x. Okay. So basically it was x raised to power minus half. Okay. And the derivative which we got was minus half x raised to power 3 by 2. So if you get to this formula, okay, n was minus half. Okay. So if I apply this formula to that one, the derivative of this one, okay, so it follows n was minus half x into minus half minus 1. So you can straight away get this form. Okay. So what you need to do, just write the formulas. Okay. Obviously now look at this one, derivative of x with respect to x. Obviously if I am measuring x with respect to x, it has to change with the same rate. Okay. So the rate is constant, and that is 1 itself. Okay. This one again becomes x raised to power minus 1, the same case. Okay. For this one again, these 4 are, I will say, same category. Trigonometry, you have to remember, plus you can derive also using that principle. Okay. Just take here sin x plus h minus sin x over h. Just open up this thing and simplify the things. You will get the final answer as cos x. Okay. Similarly for this one you can expand. For these things you can check. Okay. For 6 trigonometrics. Now this is very important. Okay. We will learn some more standard derivatives as we proceed. Okay. But for this part, this is where we should stop. Like this is enough for now. Okay. So you can practice some questions based on this. And again in the coming part we'll be practicing by both methods. I'll be demonstrating that how we will be doing by first principle and using this standard derivatives. Up to then, like before watching the next part, okay, what you can do, remember these things. Okay, go through the geometrical meaning again and understand. Okay, this is what the differentiation is. Okay, and you'll find it quite interesting. Okay. So remember this, and we will be continuing with the first principle and standard derivatives. We will do the questions, okay, in the next part. So here we are at the end of our first phase. We learnt what is differentiation, geometric meaning. In the coming part, we are going to do the question based on what we have learned today. Please learn the formulas carefully and the first principle, which is proof of all the standard derivatives. Try to solve using that at least once. Stay tuned for the next part.